Project 3.4.3 SAR ADC completed, a project inspired by Mitsuru Yamada's original project, which is linked in the description by ADC. The purpose of this project is to finish the construction of the SAR ADC by including the many D-type flip-flops, 7 AND gates, sample and hold circuit, R2R DAC, and clock. The previous two projects in this 3-part series describes how the sample and hold / comparator circuit work along with the clock, and therefore will only be touched on briefly in this video. One key concept found within the SAR that is yet to be explored this year has to deal with the D-type flip-flops. This flip-flop will output a stored logic level that has been applied into the data pin as long as the clock input remains high. If the clock input inverts to low, the set and reset flip-flops inputs are held at logic level 1, not changing states, storing the data presented on its output before the clock switches states. This means that overall the output is technically latched as either logic 0 or logic 1. The common use of the flip-flops found within the circuit are key, as the 274HE273s are constructed using said component alongside the various other ones following the 273. Within the circuitry, the 74HE273 is 8 edge triggered D-type flip-flops that all share an asynchronous MR master reset and a common clock. When the clock switches from high to low, each flip-flop will store the present value on its D input and outputs said value on Q. Since each flip-flop share the same clock, they update simultaneously. If the master reset pin is pulled low, all the flip-flops are reset, pulling their inputs low regardless of the clock state. This operation that is synchronized across all flip-flops allowed the IC to function as an 8-bit register. The chip functions as its inputs D0 through 7 receive the SAR's logic outputs, causing the corresponding Q inputs 0 to 7 to hold the final digit result until the next clock cycle. This latching effect on each of the corresponding outputs allow for the circuit to complete successive approximation. Each of the corresponding outputs, that being Q0 through 7, are then fed into 7 individual D-type flip-flops and 7 AND gates. The D inputs of each of the corresponding flip-flops store and refine the successive approximation bit. Each individual clock pulse, as mentioned previously, the flip-flops update based on the previous decision made by the SAR and comparator. These outputs are then passed through an AND gate used to force only the relevant bits to be tested at each step and not every bit used. This result of these AND gates are then fed into the R2R DAC described in the most recent project, Project 3.4.2 SAR ADC R2R ladder DAC. The final IC within the circuit is the second 74HC273, which acts as the final output register for the circuit, which stores the fully resolved 8-bit digital output of the SAR ADC. On the rising edge of the clock cycle, the 74HC273 latches the value, ensuring that a stable and synchronized digit output can be used for further processing. The Q outputs are then connected to the LED indicators, with the final register preventing any glitches or transient errors, cementing that the ADC produces a clean and reliable digital representation of the input voltage. The last IC is connected to the AND gates only to ensure that the final fully determined bits are what is being shown and that are the values that have been latched. The AND gates, as stated previously, act as a bitwise control switch, allowing the SAR logic to selectively update each bit while the approximation is still in progress. Thank you for taking the time to watch my video on the SAR ADC inspired by Mitsuru Yamada.